Hello, everybody. Welcome to today's session. I'm so glad you could join us again for our SAFMED digital webinars. Thank you so much. As a reminder, of course, this session will be recorded because all of our webinars are being recorded and hosted on SAFMED's YouTube channel. The series is kindly brought to you by SAFMED, and SAFMED is your solutions partner in both the CST and the operating room, and has been so for over 35 years now. Thank you, SAFMED, for sponsoring this. So this is webinar 2 in our series, our 3-part series on effective cleaning of instruments and devices. As many of you know, a number of our previous webinars are hosted on our YouTube channel. If you don't have access to it or you're not sure where to go, drop me an email and I can send you the links directly. Of course, with it, I will share the links to the post-webinar tests. If you do any of the post-webinar tests, you will receive a certificate of attendance. There are numerous loaded. I think Justin said we've got over 36 loaded on the system now, so lots that you can go back and learn from. Moving on to today, effective cleaning of instruments and devices. Last week, as we said in the introduction, of course, we would start with understanding cleaning, defining what cleaning is, and what we actually covered last week was, amongst others, in summary, we learned that cleaning is the critical first step in the decontamination process. We reminded ourselves that we need to clean off a variety of different types of soils, that we need to use the correct techniques, the correct chemistries, and the correct accessories when trying to clean devices, and that was very important to follow the manufacturer's instructions for use. When we were defining all of this, we actually looked at some of the examples in the instructions for use that included the use of ultrasonic cleaners. So today, that's what we'll be focusing on. So manual cleaning is done. We're going to focus on a semi-automated method, that being ultrasonic cleaners today. Next week, we'll focus on washer disinfectors and the importance of them, how to use them, what their value adds are. But today, let's get into ultrasonic cleaners. In order to clean something with an ultrasonic cleaner, you need a few basic components. You're certainly still going to need water. You're still going to need detergent. You're going to need a stainless steel bath of some sort. And you're going to need a thing called an ultrasonic generator. You're going to need a thing called a transducer and all of the bits and pieces that go with that, of course, to make them all functional. Importantly, the ultrasonic generator, that piece of equipment takes the electricity, the main electricity power, and turns it into a high-speed electronic signal. And it sends that signal to the thing called the transducer. Those are those little silver dotty things at the bottom over there. And those transducers work similarly to a loudspeaker. And ultimately, they convert the electricity, the energy from the electricity, into sound. And they put these sound waves into the water. Let's have a look at these transducers a little bit clearly, or more clearly. So that's quite a complicated drawing, and all the technical people will know and understand what these things are. And there's some pumps and various inputs and outputs and bits and pieces in there. But what we're focusing on today are these transducers. So if you look at all of those round, sort of the black bits that you can see, in the circle, those are all the transducers, and those are under the base of your bath. And as you can see, they're spread out along the base to make sure that the waves go into the water evenly, so that the whole bath is doing the job that it's meant to do. So very interesting to see how those transducers work. Let's put that in graphic format now, just to understand it a little bit clearer. But this helps us to understand how ultrasonic cleaners do their cleaning as they are meant to do. You will see, hopefully you can see my cursor now. You'll see here are the transducers at the base, under the bath. They are going to take that energy and they're going to put it into the water. So those sound waves in the water detergent solution produce tiny bubbles, hundreds and hundreds and hundreds of tiny bubbles. The bubbles will implode, so they don't explode, they implode, and with that it creates a scouring action that does the cleaning, and that cleaning process is known as cavitation. There's another graphic, and this graphic is actually the implosion of one of those tiny, tiny, tiny little bubbles that you see. Most ultrasonic cleaners operate at frequencies between 20 and 400,000 kilowatts, and they typically will use water or a water-based solution. Ultrasonic cleaners have been used in industrial applications for many, 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 many years. And ultrasonic cleaning was introduced into the health industry around the 1950s. So there it is, the bubbles in the water create this effect, the electricity, the sound waves, we get the bubbles, and the bubbles, as you can see, with all of their energy, implode, and when they implode, it gives off energy that shakes loose all of the debris. Makes good sense, I'm sure. Now, if you have a look at the image on the left, and if you've ever been in CSST while the ultrasonic cleaner is working, you would have heard that hissing noise. The hissing noise, of course, is audible to everybody, and it indicates the presence of cavitation. The bubble formations are happening. That hissing noise can be white noise and can also be a little bit disturbing and can be a little bit harsh on the ears. And I don't know if you know this, but if we have any noise in our work environment that is over 85 decibels, then we should be wearing some form of ear protection to protect ourselves from these kind of noises. So another point to think about is, what is the decibels? What does your machine give off? Look at the manual. Make sure that you are safe to use your ultrasonic cleaner in your healthcare setting. So very important to think about ultrasonic cleaning because it can be used in so many different environments and has been for years. My husband's in electrical engineering, so he used them to clean boards of things, so electronics, and they can be used. I know we used to clean our jewelry in them at, when we were still students. It would sneak in there and try to clean our jewelry. So they've been used for many different functions. So very important to try to focus on getting an ultrasonic cleaner that's designed for purpose, that one that is designed for the healthcare setting. Of course, then we want to bear in mind noise. I've spoken about this journal before, so it's a German publication called Central Sterilization, and Central Sterilization focuses completely on CSST, and they have some really interesting and complex sometimes journal publications. This particular research was performed and then published in 2020, speaking about noise protection when using ultrasonic baths, measurement, evaluation, and reduction. And the point that they made in this journal is that unlike some occupational areas, it's easy to measure noise. It's a little bit more complex when you're trying to measure the noise in the environment when it comes to using ultrasonic cleaners in the CSST, according to the researchers. But what they did find, thankfully, is that measurements show that ultrasonic baths of normal standard size do not generally pose a hazard. It's only that the risk will begin to increase if you're using several units simultaneously. So remember, if you're in a tight environment and you've got a huge amount of noise in a small place, then maybe you need to worry about protecting everybody's hearing. And under normal general circumstances, thankfully, our standard size baths are not problematic or not hazardous. Again, look at the manual of your device and make sure that it's designed for healthcare and that it's safe, not over 85 decibels. Rightio. So we said cavitation in action. The number of cavitation bubbles created in that liquid is directly related to the energy applied to the liquid. So that's why it becomes quite important to understand your device itself, because the energy applied in hertz will differ and will differ depending on what it's designed to clean. So in industrial things, you might have one that works at 400 hertz, and that perhaps is too much for what we need in our environment. So each bubble, like we said, is like a micro-compressed air hammer that ends up dislodging the dirt. And frequencies of 37,000 kilohertz and above create smaller nodes between the cavitation points, and that allows for more precise cleaning. Important. Now, this is what we want in healthcare, is very precise cleaning. The creation and the characteristics of that cavitation can be influenced by all sorts of things. And that's why we tend to need to do things like run a degas cycle in the beginning of the day or at the beginning of the cycle, depending on whether it's automated or not, and rinse off gross soil. Because if we don't do that at the end of the day, it's going to affect the cavitation process, which then means it affects the cleaning efficacy. So therefore, we are looking for a device that's gentle enough for the delicate instruments, all those instruments that are complex and intricate, but powerful enough to dislodge the burden from hard-to-reach places. We spoke last week in depth about instructions for use and looking at the manual and instructions for use for any devices that you buy before cleaning them. And things that you'll certainly find that cannot be cleaned in an ultrasonic cleaner will include things like drills or handpieces, telescopes, cameras and light leads, laryngoscope blades and handles. Those are the kind of devices that will be injured in some way if you put them in an ultrasonic cleaner. Even if they are submersible, certain things are not able to be cleaned in the ultrasonic cleaner. You'll shake all the bits loose and then that would be problematic. We referred yesterday, as we said, to some of the instructions for use, and this is an example of an instructions for use from Intuitive Surgical. This is for the original type of instrumentation for one of the earlier models of the Da Vinci. And in this, it really and truly is quite clear. It stipulates, and so it does in all of the instructions for use that I've ever read before, the amount of time that you should be putting the device in the ultrasonic cleaner for. It'll say in this case, it said these instruments need to go to the ultrasonic cleaner for a minimum of 15 minutes. They were also quite clear of the temperature. So they said 45 degrees without exceeding the recommended temperature, of course, of the enzymatic detergent, but 45 was their recommendation, as well as it might specify the PSI of the sonic irrigation. It could specify the kilohertz. So important to understand exactly what it is you're meant to be doing for that particular device before you toss it in the ultrasonic cleaner. Now, what sort of instruments will benefit from ultrasonic cleaning? Well, all of the small ones, all of the complex ones, and of course all the ones where the manufacturing actually says that this is the way they should be cleaned. Eye instruments, I think we've known for a number of years, everybody I know that scrubs for eyes has got an ultrasonic cleaner for their eye instruments because they are so small, they are so delicate, and they are quite difficult to clean. Those hinges, those joints are extremely small and narrow, and that makes them really difficult to clean. For eye surgery, you can look, here's an example out of the Katina guideline that says, at the very least, at the end of the day, please put your devices into an ultrasonic cleaner. Now, it makes very good sense to have a dedicated bath for eyes so that we don't contaminate the eye instruments, we don't have any cross-contamination issues, and of course you don't need a lumen flush for your eye instrument, so a bath is absolutely ideal and you can make use of a smaller bath in this regard. Please remember, do not leave water standing overnight in an ultrasonic cleaner. There is a possibility for the formation of endotoxins. Those endotoxins can end up on the instruments. Your patient will then end up with TAS, toxic anterior segment syndrome. Your patient can lose their sight as a result of that. Now, in the South African setting, I'm aware of a court case that involved two patients on the same list. They followed each other. The first patient happened to be a nurse. The second patient wasn't, but both of those patients, if I understood correctly, lost their sight or partially lost their sight. There was a court case. The hospital lost the court case, and the allegation was that the instrumentation was not clean that was used on them, and at the end of the day, that's what caused them to develop this eye issue, loss of sight. So please remember, looking after your eye instruments is crucial, and it's one of the instruments that can certainly benefit from ultrasonic cleaning. Other instruments that will benefit extremely from ultrasonic cleaning with sonic irrigation is lumened instruments. So anything with a lumen in it, of course, with relevance, that can go in an ultrasonic cleaner will benefit. So suctions. Things like orthopedic reamers are also quite difficult to clean. So again, consult the manufacturer's instructions for use. complex instruments. So here's one from some of the Arthrex instrumentation where they say, place the device on the ultrasonic unit for a minimum of 10 minutes and then process according to the ultrasonic unit's directions. Da Vinci instrumentation, we spoke about already in that IFU, are complex. As they've brought out the newer model, the newer ranges, the XRs, then the instructions have changed a little bit because the instruments have changed a little bit. So very important to follow those instructions. Not all processes are validated. There are some systems where you can actually also get correct attachments for your washer disinfector, where you could wash your Da Vinci instrumentation in a washer disinfector. Remember, it needs to be a validated process. So not you taking a guess and just shoving it in. You need to follow something that you know is going to work and do the job correctly. Now, I spoke earlier about suctions already, and this picture comes out of a published paper from 2012 already, and it's one of the reasons in my own research that I looked at suctions. And we'll go back to that publication a little bit later, or we'll come back to it a little bit later. But I want to really and truly want you to look at nice and clearly, so I'm going to use this red dot pointer, is what it looks like inside a suction. If you take a brush and you pop it in this lumen over here, you're going to have a brush size that can fit through that lumen, but it's not going to be big enough to clean the whole inner aspect. And that lumen is still bigger than the front of the device, which is going to be a hell of a lot smaller. So no matter which way you shove a brush in here, you're never going to clean the entire cavity of a Yankow sucker. Not with a brush. It's just physically impossible. The design of the instrument does not allow that. And that is why ultrasonic cleaning with lumen flush and this kind of device is absolutely important. So if somebody asks me to audit their unit or do a walk around in the unit, one of the things I do is I say, please give me a pus swab, and I shove it up, normally the front or the back. But remember, when I'm testing that, I'm only testing this little part over here. I can't get in here to test that section. So, and often when I do that, firstly, I can often not get the rose tip off because it's so caked on. And then often I'll find a huge amount of debris in the front or the back. If I don't find it, I'm relieved, but it doesn't mean the instrument's actually clean, because inside there, look at the design of that Yankow sucker. It is complex. And these are the things we really and truly need to think about. So we've already alluded to the fact that there are generally two types of ultrasonic cleaners that we are going to use in the healthcare setting. The one being a bath, and of course those baths are available in different sizes or different volumes, depending on your needs. And again, ideal for delicate instruments, ideal for eye instrumentation. And then ultrasonics with sonic irrigation. Sonic irrigation, absolutely critical for obviously certain lumen devices. When you have an ultrasonic cleaner with sonic irrigation, it means that the external surfaces as well as the internal surfaces are being exposed to ultrasonic energy. So what you're going to be doing is taking your instruments, let's get out the pointer again, you're going to attach them to this device over here, either using this kind of distal connector or perhaps a lure lock, depending on what's going to fit. And then at the end of the day, you'll have sonics on the outside of the instrument as well as flushed down the actual lumens. As you can see over here, all the debris coming out over here. Okay, pity you can't see the pointer, sorry about that. But what I'm alluding to, then I'll try to describe it. If you look at the images on the top, on the left, there's a device there called a distal connector. It comes in different diameters so that you can put the nose of your suction irrigation in there so that the sonics end up flushing down the lumen of all of your instruments. You're looking at using controlled irrigation, and the irrigation is going to be at a different measurement, normally measured in PSI, for example. I'm used to 45 PSI to be able to irrigate nicely. And with that, you're displacing the air out of the instrument, now replacing it with fluid, and in that you're going to ensure cavitation. So cleaning the outside of the instrument, but doing a sonic flush down the lumens as well. Some published research here is published research from Alpha. What Alpha did was Alpha took a whole of laparoscopic instruments, inoculated them with a test soil, and that test soil actually included some bacteria. They then cleaned the instrumentation in an ultrasonic cleaner with a lumen flush, and they cleaned some manually. And the ones that they cleaned manually, they just used a syringe to flush with. Her findings were that the automated method was more effective to clean with versus the manual method, so obviously ultrasonics, and that the ultrasonic cleaner was the only method that reduced the bacterial count by a log of 10 to the power of 4. So one can conclude then that in this case, cleaning lumen instruments with ultrasonic cleaning is going to be far more beneficial. So sonics alone is one thing, but it's also very important to get stuff to loosen the debris and get it out. So in this case, the lumen flush was far more effective. So all of these methods Alpha then proved that lumen flush is very effective for laparoscopic instrumentation. So when I did my research, and that was back in 2015 already, remember what I did was I went to swab over 300 instruments for residual proteins to see how well we were cleaning them in the South African setting. This research took place in 5 different hospitals in the Gauteng, 3 provincial and 3 privates and 2 provincials. And at the end of the day, if you look at the Yankau suckers, 26% of them won in the pilot study and 24% of them in the main study tested positive for residual protein. Now, the nuance around that, or the caveat, is firstly that, remember, I'm using a pus swab and I'm popping it up the front or the distal end of the Yankau sucker. I'm not getting into the bulge area. And the other part about it is I would often get debris out like that, black debris that you can see in this image over here, but it wouldn't necessarily test positive for protein because now it's changed because it's been processed so many times, but it is still there. So my percentage of 24% tested positive for protein doesn't mean I didn't get debris out. There were tons of them that I got that horrible black debris out. It tends to come up in this black clump. It's really, really very sad. So again, Yankau suckers, yes, I'm testing like this, but what about that whole bulb area that I can't get into to actually test whether it's positive or not? The only way to do that would be to cut the device open in half. So let's talk about features and things to consider, and then we'll talk about a little bit more about how to look after your ultrasonic cleaner and how to use your ultrasonic cleaner properly. Right, so things you're going to think about, of course, is do I need a bath? Am I doing eye instruments or do I need sonic flush? If I'm doing lumen and cannulated instruments, then I certainly need something for ultrasonic flush. As I said already, ideal if you to have a separate bath for your eye instrumentation. You need to think about the size of the bath, the capacity of the bath. So, of course, the manual or the instruction or the guideline or the person who sells you the bath can tell you what its capacity is, what volume of instruments can it take, what weight of instruments can it take, how many lumen flushes does it have on it attached to it, can you put in one load at a time. You need to look at the size of the bath, the depth of the bath. Will it fit the length of the instrument? So some of the Da Vinci instrumentation, for example, doesn't fit in standard baths, and you may need a slightly bigger bath for that. What are the space constraints in the unit that I'm going to be putting it in? What is do I need water? Do I need piped in water? All of those factors you need to take into account. Do I just open a tap and drain it into the sink, or do I need a proper fitted drain? What do I have available, and what can I have plumbed in? Does the ultrasonic cleaner have a series of cycles? Because some of them do, as in you can select out of a variety of different cycle types, a pre-wash, a main wash, a rinse, no rinse, or is there the ability to reuse the water so that I can wash a few times in the same water? The course, that's going to depend on your circumstances. If your instruments are very soiled, then you don't want to reuse the water. But if you're in an environment where it's really, really terrible and you don't have water, and you're in the Eastern Cape, for example, who really struggle for water at the moment, you might want to be able to use that cycle again, which may be possible if the items are not too soiled. So to use the ultrasonic cleaner, of course, you need to be able to have read the manual, and you need a copy of the manual. Now, often we end up putting it somewhere, or it gets filed in maintenance or somebody's department, and nobody knows where the manual is. If you please ask your supplier for a manual again if you don't have one. I'm sure they can give you one, because it's quite important to know how to clean them and how to disinfect them, and what checks you need to be performing on them, and how often you should service them. You saw the complex electronics and devices and bits and pieces in that original image right in the beginning, and all of those things need to be serviced. There are pumps in there that help make that water flow for the sonic irrigation, requiring servicing. Here's an example of some types of cycles on one particular device. You can see here Program 1, Program 2, Program 3, Program 4, Program 5, Program 6, all with slightly different parameters to them. A pre-wash, a main wash, a degas. You'll note that the majority of them have a degas, except for that rewash cycle, Program 2. The wash time, many times you can adjust that wash time. You can use this preset settings, or you can adjust it. Remember, you might adjust it based on the instructions for use from the manufacturer. What the rinse temperature might be, what the rinse time is, the final rinse, everything like that. So it can give you an idea of what it is you need. And hopefully your ultrasonic cleaner gives you those options. Again, some examples from a manual of the type of checks that you may need to carry out. This, of course, is going to be dependent on your make and model, but here are some examples. Visually check that there's enough chemicals. Of course, that would be your detergent. Check that the device or the pump that's meant to go into the bottle to suck up the detergent fits in correctly, and it's properly inserted into the detergent, not sort of only 3/4 up, and it's you might end up sucking air at the end of the day. If there are disposable recirculation filters in the tank, check them. If they need to be replaced, you do it as per the manufacturer's instructions for use. There may be a metal drain filter. If there is such one, how often are you meant to clean it? What are you checking for? A lot of them have got water sensor levels, so that's how it knows how much to fill in. Of course, it fills up a set amount, doesn't overflow. There's some form of sensor to measure that with, and you may need to clean those using a nylon brush or an alcohol wipe, whatever the instructions say. Check that the chamber itself is free from any debris or deposits. You may need to be doing, and you should be doing, cleaning efficacy tests. How often are you doing them? How are you doing them? And then there may be weekly checks, and that may say those weekly checks can include, in addition to your daily checks, checking the mains power cord is okay and not trapped or damaged, the plug is secure in its socket, checking the condition of the main water supply hoses, visually inspecting the water and drainage system for leaks, and running a full decontamination procedure that may include disinfection. Well, how do you do that? You have some of the examples again. The manual should tell you which ones with images, of course, what is a water sensor, and how do you actually test it. Also very important that on installation, you follow all the installation guidelines that will include putting your ultrasonic cleaner on a flat surface. If it's not on a flat surface, it could be a problem for these sensors, and if it's incorrect, you could overflow or you could have aborts continuously. Making sure that everything is fine, not kinked, the port hoses are fine, everything as per the instructions. How do you clean? How do you disinfect? So this particular example talks of wiping down all the internal surfaces above the water line with the disinfectant. Interesting, huh? This should be done daily. and inside of the lid and around the seals, and that's to remove any trace of cleaner, afterwards, that you wipe it off and you towel it dry, so keeping the lid dry as well. In this point, it's telling you that's what you do on a daily basis, because below the waterline, the tank is immersed in water and should be cleaning. And it is clean. It should theoretically be clean. But then weekly, what do you need to do? So this example includes using a sodium hypochlorite solution, putting it in a bowl. It describes the program that you need to use, how long it must stay in the washer for. In this case, the suggestion or the recommendation from the manufacturer is 15 minutes. You pause a particular cycle at a particular point to disinfect. Why are we doing that? Because we don't want microorganisms growing in our tank. It's water. It's not purified water, it's tap water. There are microorganisms in water naturally. I'll show you some images of when this wasn't done correctly shortly. So remember now that there's certain things that can impede the cleaning efficacy, and that will include not running a degas cycle. If the inlet water is too cold, of course, depending on the make and the model, again on installation, the manufacturer will stipulate that you need incoming water at a certain temperature. A lot of the machines have the ability to warm the water slightly or keep it warm, but they don't necessarily have the ability to warm it from cold. A lot of our washers are more equipped to warm water from cold, perhaps, whereas our washer disinfectors are less likely to be able to do that. So the incoming water needs to be at the right temperature. As I said, making sure it's installed flat, otherwise the water sensors are going to alarm the whole time. Gross soils on instruments is also going to be problematic, so you may need to pre-rinse your instruments before putting them in the ultrasonic cleaner. If you're not using the correct detergent, if you're not using any detergent, if you've got the wrong dose of detergent, thankfully the automated ones, as you know, will suck up the right amount of detergent. Others you may need to squirt in the detergent yourself. And of course, if you've overloaded it, so you need to know the capacity of the machine, that you don't overload it and that you don't put everything on top of everything. How you load it matters, as always. As I said, never leave the water standing overnight, please. At the end of the day, if you're going to use the machine and you're going to continuously work with it overnight, that's great. But somewhere along the line, you need to let the water out. You need to follow the cleaning instructions, as it said daily, drying off the lid, drying off everything above the waterline. The cleaning and disinfection cycle, you need to run it once a week. Why? We don't want fungal growth and we don't want endotoxin formation in the water. All right, so the image of the right over here, there's a few things to look at. Number one is the tubing itself has turned this horrendous orange yellowy color. It used to be white and clear. Now it's gone all yellowy, so something tells me that something's not going well there, and there's all these black deposits on the bottom of the tank. Why? I have no idea. I opened the lid of this particular one, and as you can see, it was moist in there, and by the looks of it, it's never really been dried. So if you're not running the machine, let the water out, dry it, follow the instructions, open the lid, let it dry out. The one on the left, you may not be able to see it clearly, but I promise you I nearly died this day because the little black spots were all fungal growth. It was absolutely amazing. So we had this black fungus growing all over that manifold over there. And you can see the different tubing. So 2 had been replaced, 2 of them were newer, 3 of them were a lot older and that odd yellowy color. I don't know if that was just the material that had changed color because it was now brittle and old, or if there was actual fungal growth in that tubing as well. So that's why we please need to follow the instructions, read the manual, get the manual if you don't have one, that you can properly disinfect and decontaminate your ultrasonic cleaner. Ultrasonic cleaners are really, really awesome devices. I really believe in them. You can see why every suction that I stick a pus swab down, I want to cry if it's dirty. And I also know that yank out, I can't see any other way to clean it. But if we don't look after them, like every other piece of equipment, if we don't look after it properly, it's not going to do the job it's meant to do. Of course, like anything else, when it comes to effective cleaning, we're going to start with wearing the appropriate PPE. Remember, it's quite warm in there, so when you open the lid, it's going to be hot. Don't just stick your fingers in. You could burn. Be cautious, please. Before loading, rinse off the gross soil wherever possible. Instruments must go into a basket. You never put them flat on the base of the sonics of the bath itself. I have seen people use silicone mats in some cases when they've got very delicate instruments. I'm not 100% sure if those silicone mats will impede some of the efficacy of the cleaning. It may do, it may not. It may protect them. I'm not 100% sure if that's a good idea or not. I understand why it's being done, but perhaps we need to make sure we've got the right bath for the right job. Never let the instruments of the devices touch the floor, touch the side walls. The instruments, of course, must be fully immersed. As normal, you would open all the joints and disassemble everything that can be disassembled. If there's small items that you're worried about, there are little devices and attachments that you can buy with small baskets that you can put the smaller items into, because you don't want screws falling off and landing up in the drain or anything weird or wonderful. Again, instructions for you. Some laparoscopic instrument manufacturers may say that certain of the instruments can't go in there because it's not good for the joints, but you must understand and know those instructions for use. Be cautious with mixing metals. If you mix brass along with other materials, you may cause a reaction in the load. The same applies with the washer disinfector. Never just open the lid. Very important to keep the lid on during the process. Now again, depending on the make and the model, some of them don't do that. You can just open the lid and then you expose yourself to aerolized microorganisms. Please bear that in mind. The lid is meant to be on through the duration of the cycle while all those bubbles are going. You're aerolizing microorganisms, you're going to inhale them, and you're going to contaminate the environment around the machine. Remember, we spoke about that last week. Some of them have got safety mechanisms that if you open the lid, the cycle will abort immediately, and that could waste a ton of water and detergent for no good reason. It might say press the button to pause the cycle, then open the lid. So again, read the instructions for use and get your in-service training. Be cautious, it might be hot. If you've used a cycle that is going to do pre-wash, wash and rinse afterwards, or wash and rinse afterwards, you may not need to rinse. But if you are reusing the water, of course, you may still need to take the instruments out of the washer disinfector and rinse them. You may also be putting them straight from the washer into the normal, from the ultrasonic cleaner into a normal wash cycle with the rest of the instruments as well. That is also quite possible and done for many instruments. Here's another published paper, and this one looked at these endodontic files. Some of them, of course, are single-use, as far as I understand. Some of them may be reusable. If you are using the reusable ones, of course, follow the instructions for you. So in this case, they did some research where they took a test group of 36 files that were cleaned ultrasonically for 10 minutes, a test group again of 36 files that were cleaned in a washer disinfector, and a control group of 18 that weren't cleaned at all. Both test groups had significantly less residual debris on them than the control group, but they found in their research that files that had been cleaned ultrasonically had far less debris on those than the ones cleaned in the washer disinfector. So again, different devices are designed for certain purposes. So an ultrasonic cleaner cleans these kind of things better than a washer disinfector does. Important to know. Of course, our goal is to prevent surgical site infections and outbreaks. So this was an outbreak of Pseudomonas that happened with patients. They ended up with surgical site infections after a whole lot of arthroscopy procedures. This happened in Texas. So they had joint space infections. And all of this resulted or related to retained tissues in the lumen of the inflow and the outflow cannulas, as well as in the arthroscopy shaver handpieces. So if they had put those, well, I'm not 100% sure if the handpieces could go into the ultrasonic cleaner, probably not, but these cannula could have. If we put those cannula into the ultrasonic cleaner, would they have had a better outcome? A very good question. Yeah, this is that research. So very soon after this incident in 2009, it became more public a little bit later, 2011, 2012, when it became public because it was a big thing in America, and interviewed the patients on TV. And as you can imagine, those patients were suing now after their joint infections. This particular hospital were now a bit nervous about lumen items and things that aren't being cleaned. So they did some research, and that research was published in 2012 in the AORN Journal, Association of Operating Room Nurses. This included that image of the Yankov sucker. So as an example, they knew that because of this now alert that came out from the FDA, because of the arthroscopy shavers, they were now worried about fragments of tissue in lumen instruments, so they decided to test their suctions. They examined suction tips from neuro trays. A total of 144 instruments were examined. So they took these instruments and they decided they'll do some form of manual cleaning, and they found out that this was really and truly problematic at the end of the day. They took them, they cleaned them manually, then they cleaned them in an ultrasonic cleaner, and those that were still dirty, they cleaned them again and cleaned them again. So here was some of the points that they found. They found that the brushes that they were using for manual cleaning, they needed all sorts of sizes, and they didn't have all of the right sizes. And remember, how do you get inside the bulge of that Yankov sucker? I have no idea. They found some of them were too soft, and they kind of just tickled at the debris and didn't do the job. And that they found also that there were several layers of debris now over time that had been packed on the inside, and in fact couldn't get it out at the end of the day. Yeah, some of the images that they had. The one on the left is organic debris found inside of a Fraser shucker. The one on the right is manufacturing defects, where the welding was not smooth on the inside, which you can't see, and ended up with this accumulation of debris on in the suctions. So of the 144 instruments, you can see now after routine cleaning, they found that 108 of them were not clean. So 108 of them still had debris in it. So they took the 108, they soaked them again, and they put them through enzymatic solution for 20 minutes, and 70 of them were still not cleaned. Then they put them in the ultrasonic cleaner again, and 42 of them were still not cleaned. They took those 42, did another soak for another 20 minutes, another 2 cycles in the ultrasonic cleaner. 17 of them were still not clean, and 17 of them never became clean. So after years of use, they realized that these ultrasonic cleaning processes we know can work and can help, but if there's a whole bunch of build-up over the years, will they ever come clean? That remains to be seen, doesn't it? So that brings us to almost the end on ultrasonic cleaners, and I think that we have proven, looking at the research and understanding what our instruments look like, that it can be very, very important to use an ultrasonic cleaner. Remember, if the court case comes, something goes wrong with your eyes, with the patients who've had eye surgery, and you haven't followed the instrument manufacturer's instructions for use, you are liable because you haven't done what you were supposed to do. If you don't have them, please get them. Ask for them. Every single device that you have available to you, there must be a set of instructions. On the weekend, 2 weekends ago, we were at the APSA Congress. There were some manufacturers there with a fancy laparoscopic device for manipulating the uterus. The first thing I said is, can I please have a copy of those instructions for use? They said, yes, we've got them. They are available. So apparently they do have them. They're off the website. They can be gotten. If you're buying things, please get the instructions for use so that we know that we're cleaning them properly. And they may very well include the fact that they need to be washed in some form of ultrasonic cleaning. So what did we learn about today? We looked at the components of an ultrasonic cleaner. We've understood how they work, how we make cavitation. We've looked at a whole bunch of factors to consider when we're purchasing an ultrasonic cleaner. I've reminded you on how to load and unload and to follow the ultrasonic cleaner's instructions for use. And hopefully we've understood the benefits of ultrasonic cleaners and their role in prevention of surgical site infections. Thank you so much for joining us today. Hopefully you can join us again next week if possible. If you don't make it live, not to worry. We will make sure you get access to the videos as normal in a day or two, not quite a day or two. Once we've edited the video, we'll send you a link to the questions, 1 or 2 survey questions and post-webinar test. If you answer that, we will email you a certificate of attendance. Thank you so much for joining us. Hope you have a great day.